You are cruising down the interstate, a massive semi-truck is drifting into your lane, and you need to get out of the way immediately. You mash the gas pedal to the floor, expecting your transmission to instantly drop a gear and rocket you to safety. Instead, your car completely ignores your foot, takes a solid 2 seconds to think about it, and finally gives you a sluggish, delayed burst of acceleration. You almost got run off the road, and the culprit is sitting right there on your center console. It is that little green button labeled Eco Mode. We are going to expose the everyday driving habits and long-held automotive myths that are actually destroying your car, killing your gas mileage, and putting you in danger. People treat that Eco button like a magical money-saving switch, but leaving it on when you merge onto a fast-moving highway is a massive mistake. Eco Mode is specifically programmed to numb your drive-by-wire throttle pedal response and force the transmission to shift into the highest possible gear as quickly as possible. This is great for crawling through stop-and-go city traffic, where fuel economy is terrible anyway, but at 75 miles per hour, it is a liability. When you suddenly need power to pass, the computer actively fights you. It wants to stay in overdrive to save fuel, so it delays the downshift, leaving your engine lugging at low RPMs under a massive thermal load. If you are doing highway speeds, you need to turn that green light off and let your engine breathe in normal or comfort mode, so you actually have the HP and lb feet of torque available exactly when your right foot demands it. We are about to look at some massive mechanical failures caused by incredibly simple everyday habits. But before we get deep into the technical details under the hood, if you want to stop overpaying for repairs and learn how your car actually works, go ahead and hit that subscribe button right now so you never miss a garage session. Speaking of everyday habits, let us talk about the dashboard warning light that everyone loves to play a dangerous game of chicken with, the low fuel warning light. So many drivers treat a 15-gallon gas tank like a personal challenge to see exactly how far they can push it below the empty line before the engine sputters out. Doing this is an absolute death sentence for your electric fuel pump. In almost every modern vehicle, the high-pressure fuel pump is physically submerged directly inside the plastic gas tank. Automotive engineers designed it this way for a very specific thermal reason. The gasoline itself acts as the primary liquid coolant and lubricant for the internal electric motor of the pump. When you consistently drive around with less than a quarter tank of gas, that pump motor becomes completely exposed to the air inside the tank. Without that protective bath of liquid fuel pulling the heat away, the pump runs blazing hot and completely dry. The internal copper windings break down, the bearings wear out prematurely, and you are slowly killing a part that usually requires dropping the entire rear subframe and exhaust system just to access. On top of that, driving on fumes forces the system to rely heavily on the filter sock at the very bottom of the tank, pulling in whatever microscopic debris has settled there over the years. This restricts the flow like trying to suck a thick milkshake through a tiny straw, which eventually leads to clogged fuel injectors, a terribly rough idle, and random engine misfires. Do your wallet a massive favor and pretend the quarter mark is the new absolute empty line. That brings us to another massive misconception about vehicle maintenance that repair shops absolutely love to keep alive: the infamous 3,000-mile oil change interval. If you look at the top left corner of your windshield right now, there is probably a little clear plastic sticker from a quick lube shop aggressively telling you to come back in 3 months or 3,000 miles. That number is a complete relic from the 1970s. Back then, engines were built with incredibly loose manufacturing tolerances, and conventional base oils broke down into thick, nasty sludge very quickly under engine heat. But the automotive industry has completely moved on. Modern engines are machined with incredibly tight clearances, and full synthetic motor oils are chemical marvels, designed to withstand extreme thermal breakdown and shear forces. Unless you are exclusively doing extreme heavy towing or driving a dedicated track car, changing your fully synthetic oil every 3,000 miles is just taking $60 and throwing it directly into the recycling bin. Check your actual owner's manual. You will likely see the recommended interval is anywhere from 7,000 to even 10,000 miles for normal driving conditions. The additive packages in modern oil are incredibly robust. You are not protecting your engine by changing it excessively early. You are just funding the quick lube industry. We need to talk about the absolute most frustrating reason cars leave people stranded in parking lots, and it has nothing to do with the internal mechanics of the engine itself. You walk out to your car after a long day at work, turn the key, and instead of the engine cranking to life, you just hear a rapid, aggressive clicking noise from under the hood. Most people immediately assume their battery is completely dead or their starter motor has violently failed. But more often than not, the actual problem is hiding in plain sight under a layer of fuzzy white and green crust. I am talking about severe galvanic corrosion on your battery terminals. This happens because of a natural off-gassing process where sulfuric acid vapors leak slightly from the battery casing and react with the lead and copper metals on the terminal clamps. This crust is not just ugly, it is an incredible electrical insulator. It creates massive resistance at the primary connection point. Your battery might be perfectly healthy and fully charged, but that crust prevents the hundreds of cold cranking amps from actually reaching the starter motor. Even worse, while the engine is running, your alternator has to constantly fight through that massive resistance wall to push a charge back into the battery. It forces the alternator to operate at maximum output capacity all the time, generating extreme internal heat that will eventually melt its internal diode bridge. You will end up paying hundreds of dollars for a new battery and a new alternator, when the entire situation could have been permanently fixed with a $2 wire brush and some baking soda mixed with water. Make it a strict habit to pop your hood once a month and physically inspect those metal clamps. I am going to show you how a completely invisible aerodynamic force is quietly stealing your gas money right now. But before we break down that critical engineering flaw, if you are finding this mechanical breakdown helpful, take a quick second to hit subscribe so we can keep saving you serious money in the driveway. This brings us to the ultimate summertime automotive argument that has divided families on road trips for decades. You are driving down the highway on a sweltering 90-degree afternoon and you want to save gas. So you reach over, turn the air conditioning completely off, and roll all four windows down. Your dad probably taught you this trick, claiming that the AC compressor robs the engine of horsepower and drains your fuel tank. Well, your dad was technically right, but only for cars built 30 years ago. Back in the day, massive, inefficient cast-iron AC compressors required a huge amount of mechanical force from the engine belt just to turn, which absolutely destroyed your MPG. But modern automotive engineering has completely solved this issue. Today's variable displacement compressors are incredibly lightweight, highly efficient, and place a completely negligible parasitic draw on the engine block. On the flip side, rolling your windows down at anything above 55 miles per hour completely ruins the carefully engineered aerodynamic profile of your vehicle. It turns your sleek, wind tunnel-tested cabin into a giant, drag-inducing parachute. The physical air resistance pulling backward on your car is massive because aerodynamic drag squares with velocity. The faster you go, the exponentially harder the wind pushes back. The engine has to work significantly harder, burning way more fuel, just to push through that invisible wall of turbulence and maintain highway speeds. The mechanical drag of modern air conditioning is vastly less than the aerodynamic drag of open windows. Official engineering tests have proven time and time again that if you are driving at highway speeds, rolling the windows up and letting the climate control do its job is significantly more fuel efficient. The only time the windows down trick actually saves you gas is when you are crawling through slow city traffic below 40 miles per hour, where aerodynamic drag is practically non-existent. Let us move from saving fuel to buying the right fuel. You pull up to the gas station pump and you see three different buttons: regular 87 octane, mid-grade 89, and the ultra-expensive premium 93 octane. The premium button is always heavily marketed with words like ultimate performance, maximum cleaning power, and superior engine protection. So, wanting the absolute best for your daily commuter car, you decide to treat it to a tank of the expensive stuff. You are completely wasting your money. There is a massive psychological myth that premium fuel contains more actual energy or is somehow a purer, higher quality liquid than regular gas. That is completely false. The octane rating is simply a mathematical measure of the fuel's physical resistance to premature detonation, also known as engine knock, under extreme cylinder pressure. High-compression performance engines and heavily turbocharged sports cars physically require 93 octane because their cylinders squeeze the air and fuel mixture so tightly that regular gas would literally explode too early and destroy the aluminum pistons. But if you drive a standard naturally aspirated Honda, Toyota, or Ford that the factory specifically tuned for 87 octane, putting premium in the tank does absolutely nothing. The engine computer does not magically extract more horsepower, your fuel economy will not improve, and it does not clean your intake valves any better. because all grades of top-tier gasoline are federally required to contain the exact same detergent cleaning additives. Always check your owner's manual or the sticker on the inside of your fuel door. If it does not explicitly say premium fuel required, keep your hard-earned cash and press the 87 button every single time. Since we are talking about exactly how engines operate efficiently, let us kill one final wintertime driving myth that refuses to die. It is a freezing cold morning. The windshield is covered in thick frost, and you go outside to start the car. You leave it sitting there, idling in the driveway for 10 to 15 minutes to let the engine properly warm up before you put it in gear. People genuinely believe that a cold engine needs to sit and idle for a long time so the thick oil can circulate and prevent severe metal-on-metal wear. While this was absolutely true in the era of carbureted engines from the 1980s, modern fuel-injected cars do not need this at all. When your car is sitting there idling in the cold, it is literally getting 0 mpg. It is the absolute most inefficient way possible to warm up a motor. Furthermore, an idling engine takes a very long time to generate internal heat. Because the block stays cold longer, the computer runs an open-loop, rich fuel mixture, meaning it dumps extra unburned gasoline directly into the cylinders to keep it running smoothly. This excess liquid fuel actually washes the protective layer of oil right off the crosshatch cylinder walls, significantly increasing internal friction and piston ring wear. The absolute best way to warm up a modern vehicle is to start the engine, wait about 30 seconds to ensure the oil pressure has fully stabilized throughout the block, and then simply drive away gently. Driving puts a physical mechanical load on the engine, which forces it to reach its optimal operating temperature significantly faster than just sitting in the driveway. This also warms up your transmission fluid, differential gear oil, and wheel bearings all at the exact same time. Obviously, do not floor the throttle and redline the tachometer while the temperature gauge is pegged on cold, but normal, gentle driving is exactly what your engine wants. You will save dozens of gallons of gas over the winter and significantly reduce internal engine wear. Taking proper care of your car does not always mean buying the absolute most expensive fluids or strictly following the mechanical advice your grandpa gave you 40 years ago. Automotive engineering moves incredibly fast, and keeping up with the actual physical science of how your vehicle operates is the only real way to maximize its lifespan and keep your wallet completely intact. Whether it is knowing when to actually use your air conditioning system, confidently ignoring the premium fuel pump, or realizing that your dashboard eco button is actively working against you on the fast-moving highway, a little bit of technical knowledge goes a very long way in the garage. I want to hear exactly what you guys are dealing with in your own driveways right now. Jump down into the comments section and let me know the weirdest mechanical issue you are currently facing. Any strange check engine light codes you have pulled recently, what kind of fuel mileage you are actually getting, or even just how many miles you have managed to squeeze out of your current daily driver. Let us get a massive conversation going down there and help each other diagnose some real problems. If this video helped you understand your car a little bit better today and saved you some cash, do me a huge favor and smash that subscribe button. Hit the like button to feed the algorithm, and keep wrenching smart. I will see you all in the next garage session.